throughout this show. All fun. They enjoy their job. They do a lot of nice things. You're going to see a lot of experiments or some of the materials that we utilize in lab all the time. With that being said, I'm going to do a round robin now to start some of the other chemists and engineers that you will see.
Hi, my name is Patricia Hernandez. I am 20 years old and I'm actually an intern at Sandia National Labs. I am currently studying at UNM and I'm getting my undergrad in Spanish and chemistry. Now we'll go to Alyssa.
Hi, my name is Alyssa. I'm 19 years old and I'm currently a student intern here at Sandia National Laboratories. I've been here for more than 2 years and I'm also studying chemistry at I grew up here in Albuquerque, New Mexico, and I graduated from Albuquerque High School.
Hi, I'm Dr. Marissa Ringgold. I've been at Sandia for a year and a half. I've lived all over the United States, but I did my undergrad at the University of San Diego in San Diego, California.
James, Sandia, you all are muted.
Someone muted them.
So we're good to go?
Were we muted this whole time?
Yes. Just keep an eye on that mute button. Thank you.
Okay. I got my undergrad degree in chemistry at UNM. I've been at Sandia for about 4 years, and I'm applying to grad school this semester for material science and engineering.
Hey everybody, my name is Harold Lee. I'm from Virginia, science and chemistry from Old Dominion University. And then I went on to get my PhD in material science and engineering from Norfolk State University. I've been at Sandia for about a year now, and I'm a postdoc under Rico.
Hello everybody, my name is Avi Bregman. I'm originally from Nashville, Tennessee. I went and got my bachelor's out of Philadelphia. I then went on to study material science and engineering at the University of Michigan, go Glue. While I was in graduate school, I studied materials to go inside of your phones and computers to help with electronic functionality. After that, I moved out here to Albuquerque in January to start as a postdoctoral researcher working for Lurico Treadwell here at Sandia National Labs. While I've been here, I've worked on a lot of cool things like additive manufacturing and making cool high-strength composites on a daily basis. Fun doing things like burning stuff and smashing stuff and generally just having a good time in lab. Hope you guys enjoy today.
All right. I would like to visit scientists Alyssa and Patty. Alyssa and Patty has been in my for 2 years now. Alyssa, how did you start in science?
My junior year of high school, I got nominated for the STAR program, and through that, I got to work with Rico during the summer. And I really liked working in the lab, and he really liked having me in lab, so he offered me a year-round internship, and I've been here.
Patty as well?
So I met Rico through a UNM program called the Hands-On. This is an event held for kids all ages, and you go and Sandia sends out engineers, chemists, biochemists, and you meet them. And I asked all the right people, asked me to work for him during the summer, and then he liked my work ethic, and I've been with him for about a year now.
So we picked these two examples to say that one of the things UNM and Sandia does is a strong collaboration. We take a lot of their students as well as we give them experience in our laboratories. And during that time frame, they work on a lot of things in research and lab that currently helps us solve very tough questions and challenges. Overall, Sandia, because I didn't give this background earlier, overall Sandia is comprised of material scientists, chemists, engineers, a variety of engineers all the way around. What we tackle the nation's toughest challenges and problems, which is how we're able to keep our jobs and keep funding here. Opposed to that, we also partner with UNM very heavily. So with that being said, we're going to get into some fun experiments for you today. We're going to start off with our Iceman, Avi.
Hold on, Rico. We should talk about lab safety first.
You're absolutely right. If it is very important because without safety, people will get hurt. So with that being said, before we do any type of experiments, none of my colleagues are ready for any type of to show you any type of experiment. One, because their eyes are not covered, so which is one of their 5 senses that they have to protect. So how do you protect your eyes?
Goggles, face shield.
Goggles. Everybody put your goggles on. Everybody's protecting our eyes. There are other senses that we like to protect as well, which are our sense of touch. How do you protect your sense of touch?
Gloves.
Gloves. So everybody has to put on their gloves. If you can already see, they're wearing their lab coats, so they're protecting their body as well as clothing there. Other senses that we like to protect are our nose, but given that coronavirus is hit, we all have to wear these masks and stay 6 feet apart already, so our nose is particularly covered. Any other chance we would get to protect our nose is in a fume hood. Also, we would like to protect our ears. We're not doing anything that would make a loud noise, no explosions here. So with that being said, we do not have to put in our earbuds today. So if you look around to the colleagues now, they have their gloves, their lab coats, and goggles. They're ready to actually do some experiments for everyone now, right?
Yeah.
With that being said, we're going to start with Iceman Avi.
Hello, everybody. Come this way. So behind me, no, go for it. Go for it. Yes.
And everybody remember to pin James Nicholas's video so that you can see what's going on. The pin is located, if you hover over their video, you can see the push pin symbol. Go ahead and push that.
Okay. All right, everybody. So we're going to talk about the states of matter. We're going to do with a very cool experiment at the end, but first I want to give a little bit of introduction. So, who out there knows the 3 types of matter? You can type into your chat window. Maybe we can hear some responses.
That's right. Solid, liquid, and gas.
All right, very cool.
Good job, Smith.
Good job. Can anybody name a solid for me?
Ice.
Ice.
You got one? All right,
Got
can we
one.
name a liquid?
Juice.
Juice is a liquid?
Water.
And water. All right, and how about any gases?
Carbon dioxide.
Carbon
Steam,
dioxide. Very
water
nice.
vapor.
Very nice. Okay. So one thing that's very cool in material science and a lot of the work we do here is that we work with all 3 states of matter. We work with solids, liquids, and gases. And what we're going to do today is do some experiments involving solids, liquids, and gases. Now, when we think of solids, we think of things we can see, like you said, ice. We can hold them, we can touch them. When we think of liquids, we also think of things that we can see, we can keep in containers, kind of like water or juice. Generally, when we think of gas, we think of it as something that we can't see. It's around us. It's the air we breathe. They're odorless. They're colorless. But in fact, what I want to show you is that we can actually visualize gas in real time. So I'm going to be working with some very cool materials. So that's why I'm going to put on some special gloves. And why I'm also wearing a face mask. I want to make sure that I'm not exposing my eyes. So, what you're seeing me pour right now is liquid nitrogen. It's very, 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 very cool. You guys know of any cold things? What's the coldest thing you can think of?
Liquid ice.
Liquid ice?
Liquid nitrogen.
Liquid nitrogen.
Dry ice.
Dry ice?
Ice cream.
Ice cream? Anybody else? Well, that one didn't have any in it. So I heard dry ice, I heard ice, I heard ice cream. Liquid nitrogen is in fact colder than all of those. Liquid nitrogen is about 3 times as cold as ice. And now if you look inside the bucket here, not too close, James, we can actually see all 3 forms of matter. We have a solid bucket, we have liquid nitrogen down in the bottom, and then above that you might be able to see these clouds of vapor. What you're seeing here is actually water that's above the liquid nitrogen. And because the liquid nitrogen is so cold, it's actually vaporizing the water in the air that's sitting right above the layer of liquid nitrogen. So this is analogous to what happens when you look in the sky and you see a cloud. Those clouds are so high up and so cold that the water in the air up at that level begins to condense, and then eventually rains and turns into rain down on the ground, and then it'll freeze and turn into ice, evaporate, turn into gas, condense back into water. And that's why we don't run out of water on the planet. Now, what's very cool is that you're actually seeing a transition between 2 different states of matter. You're seeing liquid go to gas, and we can also have gas go to solid, solid go to liquid, and this can happen in very different forms. And the way we usually do that is with a temperature change, but it usually happens very slowly. It's not very exciting to watch water freeze and turn into ice, or to sit there and watch an ice cube turn into gas. But what we can do is we can initiate a change in the state of matter very quickly by working with something that's very cold, like liquid nitrogen, and say if we took something very hot, like a thermos of hot water. What we might expect is that the liquid water is going to be really, really hot. It's going to hit very, very cold liquid nitrogen, and then something might happen. Does anybody have any guesses as to what might happen?
Corey, go ahead and put your guess in the chat.
Triple steam.
Steam? Well, we've
Steam will
had
come
some good
out.
guesses, and I figure there's only one way to find out. So if James will step back a little to a safe distance, if I can get a countdown in the chat, 3, 2, 1. Our very hot water hit the very cold liquid nitrogen and instantly vaporized and turned into clouds. Thank you guys very much for learning about states of matter with me. I hope you enjoy the rest of the experiments today.
Do anyone have any questions? Was there any questions put in the chat? All right. With that being said, we're going to go to our next experiment. Everybody come me. We're going to go over to Alyssa. Alyssa, take it away.
Hello again. Our next experiment, we're gonna make some elephant toothpaste. All you guys have probably seen this done on like TikTok, YouTube, and everything. So in our graduated cylinder here, we have a mixture of our hydrogen peroxide and dish soap. And I'm gonna put this on the floor so I don't make a
They're muted.
You all are muted.
Do you want me to restart?
No, you're fine.
Okay, so we have our hydrogen peroxide and our dish soap in our flask, and I'm going to add some potassium iodide to make the reaction go faster, and hopefully it'll foam up like crazy. So if you want to come down here, I'm going to open this up.
You're muted. It's muted.
Okay. So now our elephant toothpaste is going. Does anyone know why this works?
No.
Okay. The hydrogen peroxide that we use releases oxygen gas, and that reacts with the dish soap and makes this foam. To make our reaction go faster, we added a special chemical called a catalyst. Does anyone know what a catalyst is?
No?
Okay. A catalyst is acts like a lightning strike in chemical reactions and makes them go really, really fast. And so the reason ours went so fast is because when we added the potassium iodide, it caused the hydrogen peroxide to release oxygen gas really, really quickly. And this is why this works. Do you have any questions?
I don't see any questions.
Okay. Thank you, guys.
Awesome. I hope that everyone learned about catalysts, and so far everybody's learned about different states of matter. And just a quick note, because I didn't say this earlier, you do not see me with my lab coat on or gloves. I'm not participating in any experiments, and I'm far enough away to where no danger could come with me. So with that being said, we're going to go to our next experiment. We're going to go to Patty. Take it away, Patty.
Scientist Patty here, and I'm going to show you an experiment. Have you guys heard of yuck or oogla? No comment?
Yes, they have.
They have. Does anyone know what it's made out of?
McKay, can you write it in the chat?
I see a lot of no's, and I forgot.
So
Baking soda and water?
no, close. What you do need is cornstarch. Does anyone know what cornstarch is used for?
Yes.
Yes. So you probably have this in your pantry. So we're gonna put some cornstarch in this Ziploc baggie. If I can get it open. That looks about enough. And then we're gonna add some water, which I have here. Another safety thing, we always have what the liquid or the chemical inside is. I'm gonna open this up and add the water in.
Yeah.
We're gonna close the Ziploc bag and we're gonna mix it. At the corners, a lot of cornstarch likes to stick in there. As you can see, mine is still very dry, so I need a little bit more water. And this is how it looks. So here we have a big tub of oobleck.
Can you all get the camera a little closer?
It's oobleck.
And I added some food coloring in there because I really like pink. And does anyone know what kind of fluid this oobleck is? So this is a non-Newtonian fluid. What this means is that when you put pressure into it, look, it becomes a solid. But once you let go and no pressure is added, it starts to become a liquid.
How does that work?
So that's just how non-Newtonian fluids work. They kind of seize up with pressure. Another non-Newtonian fluid you guys might use on a daily is ketchup, but this actually acts the opposite. Once you add pressure, it becomes liquid. That's why we shake it up before we use it. With this being said, do we think scientist Alyssa can run through this tub of oobleck without sinking in? Yeah or no?
They say yes. Some say no. Let's find out.
You won't be able to do it. Okay, yeah. So she's gonna stand in it and then watch what's gonna happen. She's gonna start sinking in, as if she was standing on quicksand. Okay, you can get up now.
No, I'm stuck.
Uh-oh.
Next experiment.
Awesome. I'm glad. I hope everyone learned what a non-Newtonian fluid is. We will take more questions at the end if we need to go into a more detailed explanation, as well as catalysts, as well as different states of matter. With that being said, we also have more.
You guys got muted again. There you go.
And your camera's off.
So we don't.
Nope, it wasn't.
Okay, so we'll repeat that. I hope everybody found the yuck experiment to be excellent. Hope everybody learned what non-Newtonian fluids are, as well as different states of matter, as well as catalysts. Next, we have more experiments lined up for you guys and gals. So what we're going to do now is switch the viewing over to Larico Chartwell's. We're actually going to film inside an actual lab now. Thank you.
Have you up? Ready, Harold? Can everybody see?
Your camera is half.
Yes, so now everybody move to Treadwell's, Dr. Treadwell's video and go ahead and pin that video.
How do I do that?
I'll let you know.
How do I do that?
You hover over where it says Larico Treadwell, you hover over the video and you'll see a push pin icon. Push that pin. And Dr. Treadwell, you are now muted. Sorry.
Who's?
See.
That's perfect.
All right. Can everybody see? All right. I think we're good to go.
All right. So here we are in a real lab now. So the experiment I want to show you all involves a fume hood. So you look at these liquids in here, you may say, hey, why do we need a fume hood for water? Well, these two quite, they're not just water, okay? So what I want to show you all, I'm going to say, hey, can I use these liquids to make these cups disappear? Let's see. First off, both these liquids look the same, right? Well, which one do you think is water? The left or the right? The right. Okay, so let's test it then. So, a typical styrofoam cup, you use it to drink water out of, right? So, styrofoam cup just floats in it, right? But this liquid on the right looks like water, but not quite water. For some reason, this liquid just completely makes our cup melt for some reason. Well, why is that? Well, even though they both look like water, the one on the right is something called acetone. Acetone is a good solvent for these cups right here because a solvent can dissolve. So these cups are made out of plastic that acetone can actually completely dissolve. And what you see here is that you see all these bubbles in this liquid because styrofoam cups are mainly air. And so as the acetone dissolves all the plastic, you get nothing left behind except for melted, completely disintegrated plastic. And there go our cup, completely gone. So whenever you're in the lab, make sure you label your liquids because even though they look the same, they can be completely different things.
All right. I think now we got.
Hi, everybody. Dr. Marissa again, and I'm going to do an experiment about luminescence. Is anybody afraid of the dark? Sometimes
Yes.
I get a little afraid of the dark too. But with luminescence, you don't have to be afraid. Does anybody know what luminescence is?
You get a lot of yes, me's, no's.
Can someone tell me what luminescence is?
No. Yes.
No? Okay, well, luminescence is when an object emits light. Kind of like when you turn on the light bulb and they start to glow, but instead of being powered by electricity, they're powered by a chemical reaction. So one that you guys might be familiar with are glow sticks. You can hit the lights, please. So when you snap a glow stick, that sound you hear is a vial breaking, and as you shake them together, you mix the two chemicals, and so much energy is produced that they glow. The different colors have to do with the type of dye that's used, but the basic chemical reaction is pretty similar. These chemicals react in such a unique way that so much energy is produced, and these molecules can't hold on to that energy. They try, but eventually it has to be released. It's released as light. Another example of luminescence is bioluminescence. And bio means that it has to do with life, and in this particular case, animals. If you've ever seen fireflies, glowing jellyfish, or even algae, they're all experiencing bioluminescence. They have a chemical reaction that happens inside of them that releases light. So, we have these two liquids here, nicely labeled as Harold told us they should be. You see that they're both pretty see-through. One's colorless, one's yellow. And we're going to try to see if we can wrap these together to produce light. So, pour a little bit into the speaker. Can you guys count me down? From 3, 2, 1. So now let's try to see if we can get it to go through this tube. Okay, ready? 3, 2, 1.
Can you get the camera a little bit closer? There you go.
So in this reaction, we have something called luminol. And it's a chemical that's used by crime scene investigators to detect evidence at the scene. So this luminol reacts with metals, particularly iron or copper, and when those two come into contact with each other, you have a decomposition reaction, which breaks things down, and so much energy is produced that it glows blue. So I hope you guys enjoyed, and now we're going to go on to Avi's experiment.
All right, guys, me again, the Iceman. We're going to talk about more states of matter. I'm going to be working with very cold things again, so I'm going to put on extra layer of safety and make sure to keep my face shield on to keep my face safe from any vapors that might come about. So, what we looked at last time, we looked at a transition from a liquid to a gas. And so I want to start again by talking about another change in the state of matter that we can do, which is let's take a gas and condense it down to something that might resemble a liquid, but be a little closer. We can actually visualize this with a balloon. Inside of a balloon, we have a bunch of air molecules, and they have so much energy that they're bouncing around inside, keeping the balloon inflated. If we try to smush this balloon, we can't do it because not only is the backing of the balloon so rigid, but because the molecules in there have so much energy that we can't push them down. We can't compress them enough. We don't have enough pressure. But one thing that we can do is we can slow these molecules down to the point where they're not bouncing around anymore. And what it might just allow it to do is to compress this balloon and move the molecules closer together. So, I can take a balloon, put it into a container of liquid nitrogen, and push it down. And because it's going to compress so much, I can actually just keep adding balloons to this container, pressing them down, and I can make them fit into a space where they wouldn't normally fit. I don't know if you're able to see, I was able to get about 5 balloons into this container. And you might be wondering, Avi, you're taking these balloons and smushing them down, could they possibly come back to their original form? The answer is once we let these things start warming back up to room temperature, the molecules inside them will gain energy back as they warm up, and you'll see that these balloons will begin to inflate again. So what we're doing right now is we're actually visualizing these balloons going back to their original air-filled state. If we give it enough time, everything will go back to normal and they will take on their full size again. So that's one way which we can visualize pseudo changes in states of matter. Another thing we can do is we can use liquid nitrogen, which is very cold, to freeze things. I don't know if you guys have ever tried to break water with a hammer. It doesn't really work. The hammer just goes through the water. That's because the water molecules inside that make up water, they're so far apart, and they're not condensed that when you put a hammer through them, they just move apart and make space for the hammer to come through. Now, you can break ice, though, because those water molecules are very, very packed. So when it gets an impact on them, say from a hammer or from the floor, they have nowhere to go and they shatter. Now, for instance, it would be fun to break ice, but maybe you've seen that before. But maybe we could try to break something a little different, maybe a marshmallow or an orange. See if we can break a marshmallow, huh? Doesn't really do anything. Marshmallows, they're pretty squishy. They don't really go anywhere. An orange, same thing. Doesn't do anything. It just kind of squishes. But what we can do is using liquid nitrogen, we can actually freeze the water that's inside of a marshmallow or inside an orange. And what it allows us to do is to break it like a piece of ice. So we can do that with marshmallows. We can do it with pieces of an orange. We can also do it with other things like hard to work with these gloves on sometimes. Also do with other things like, oh my gosh, a green pepper, which you can see is already breaking up. Come on. Is what science is. It is fun and a heck of a good time. So thank you for joining me today as we learned about the states of matter and we smashed things and generally had a good time. I think we have one more experiment for you and we're going to switch over to the other camera.
All right, guys, we're going to switch back over to Dr. Treadwell.
All right, do we got the video back?
No, we can't see you.
Do James Nicholas.
Perfect.
All right. So far, I hope everyone has enjoyed all the experiments. We still have one more left. And so, like I said, if you have, please put them in the chat. We will be gladly to answer any questions. At the end, we're also going to do a round robin too, to where we'll have everybody in the background want to ask a particular scientist a question. You more than welcome to, as well as myself. Also, if you would like a potential intern at Sandia, please get in contact with, I would say, our manager who allowed us to have this, which is James Carney. I will give information out later. But now, if you come walk with me, we'll come into the front of the experiment. We'll come walk into the front of the experiment. We'll get it started. Has anybody seen the Mentos and soda trick?
Yeah.
Awesome. So here we got 1, 2, 3, 4, 5 different sodas. Ready for Mentos to be dropped in them. We have Fanta Orange. We have Sam's Cola. We have Diet Coke. We have Sprite and cream soda.
The best one.
So, out of all 5 sodas, which soda do you think will have the highest reaction? Do anyone think it's cream soda? Do anyone think it's Sprite? Do anyone Diet Coke?
Coke is the one.
Diet Coke.
Coke? Coca-Cola?
Coke. Coke.
Fanta Orange.
Yes.
All right, I heard some yes for Fanta. I heard yes for Coke. I heard nothing for cream soda. And everybody says Sprite sucks. That's what I heard. So, with that being said, we'll allow them to pour the Mentos, but we're going to count them down to 5. All right? So, we're going to go 5, 4,
3, 2, 1.
One. Let's go.
So, Coke won! Who said Coke?
Wow. Let's go.
All the thumbs up.
I did. I did. Me too.
So, who
Me
said
too.
Coke?
I did.
Great job.
Dylan Trickle. I did.
Coke actually won.
Me.
So, now that comes to the end of all our experiments. Do anybody want to ask any questions? Provide any feedback? Happy to answer anything.
The coronavirus.
Best part of your job. What is the best part of my job? I would say the best part about any STEM job is to be able to answer the tough questions and make something new every other day. So that's very rewarding, as well as being able to spread science and joy throughout, like we're doing now. We find that really rewarding.
Somebody, you guys are muted again.
I think the job is that every single day I learn something new, which is really cool. I like learning a lot, and I learn every single day, and I learn a lot.
I'm gonna get the propel.
What the?
I'm gonna get the propel.
Part about this job is I do at things, and I get to research stuff that's no one ever done before. And I get to work alongside really smart people like Rico and all the postdocs here who have PhDs and have been to school for so long, and I think that's cool.
My favorite part about the job is it's so dang fun. Every day we go in, no days are bad. Everybody's always smiling, laughing, having stuff. Furthermore, the types of research and the work we've gotten to do, it's taken me all over the country, meeting new people, learning new things. Hopefully, eventually, it'll take me around the world as I get to go travel and maybe go to conferences and work with other people in other countries that are working on similar and even more exciting problems.
Well, to me, I think the best thing about the job is being able to let your imagination. A lot of us have imaginations. We want to make things that haven't been made before. And being in a STEM career field, we get to do that. Anything you can think of in your mind, you get to go in the lab and try it. And I don't think any other job lets you do that. So that's the best thing for me.
I agree with mostly everything that. So here I get to solve problems, figure out how things fit together and work all the time, and it's always something new and exciting. So you're never bored.
So do anyone else have any questions?
Somebody was asking if you work with SIPI, or have any of you ever worked at SIPI, the Southwest Polytechnic Institute?
Personally, I have not professionally.
Oh, you guys are muted again. Sorry.
Honestly,
muting them.
I've heard of SIPI. Usually, I think Amy Tapia is on the call. We work with her a lot. So her various organizations that she puts in the light as well as sponsor, we work with them a lot. So, but that's the first time I've heard of SIPI. I will have to look into it. Any other questions?
Did you guys, they keep muting me as well. What other types of jobs have you ever worked at?
That's a very good question. For me, this is actually my first job out of my postdoc. I actually did my postdoc here, and then I got converted to staff. Before that, like I said, I was in school. I think mostly everybody that did not have a job before.
You're muted.
You all are muted. There you go.
Before I got into research, I was actually in the Marine. So definitely a stark difference in one it's more physical. Using your mind, let your imagination flow. It's definitely a difference.
I've spent most of my life either in school or working in different types of labs. So I spent time working in a biophysiology lab where I worked on mice, and I spent a lot of time dissecting mice and looking at their kidneys. I also spent some time working in a paleobiology lab, so I studied DNA of ancient plants, plants that are about 500,000 years old. So that was pretty cool.
and I also spent some time working in a chemistry lab. So I've been in research and in labs my whole life, and this just has felt like a very natural extension and continuation of that process.
Is it? No one else has. Oh, I'm sorry. Well, one of the things I want to point out and add, because I know we're getting short on time. We got 10 minutes left, so I want to get to everyone's questions. Having a STEM degree is great. You can reinvent yourself numerous times in numerous occupations. It does not mean that you're confined to a lab. There's a lot of people with PhDs and chemistry degrees that are managers. One of my colleagues is also a weatherman. So that's one of the things he got his background in. I know some that are models, some that are actors. Like I said, there's a lot of variations to getting a STEM degree as far as occupation. So by all means, you're not stuck at all just in a laboratory. So with that being said, that's why you see people from the Marine Corps, different labs. So again, a STEM degree means that you're very versatile in the things that you can do and accomplish.
Let's do two more questions. One is Jennifer asked you a question about advice for students preparing for a science fair.
That's a good question, because several of us have participated as science fair judges before. One of the things that we like a lot is the explanation. So having a cool experiment is good, but if you can't explain it, it also can conduct points away from you, get points taken away from you. So make sure you really understand what your science fair experiment is. Again, the presentation helps a lot. So again, not having a last minute presentation where things are everywhere, but nice, neatly organized to where it's presentable is always two good tips for every science fair, especially if you're getting judged.
Nice. There's been a couple questions about can we do this at home? And one final question, do you have an Instagram page?
Yes. I think everybody that you saw today has a social media outside of work, whether it's from Facebook to Instagram to Snapchat. So all of us have that. So again, we're not all stuck in the lab. We also have lives outside the lab. So yes, we're definitely on social media. Can you do most of these experiments at home? Well, you cannot order liquid nitrogen at home. Let me say that first. You have to be at a laboratory to be able to do that. But the yuck, the cornstarch and water, yes, you can. The soda and Mentos, those are all bought at the store, the grocery store. Those two experiments you can definitely do from home.
Nice. And how many internships do you accept each year?
Each year, this year I picked up 2 more interns. So they were not in the video this year due to school. But what we typically do is we post a application site to where you can go and apply. We take different resumes, as well as the various programs that Amy Tapia supports. We also get resumes from there, from different high schools as well as universities. So we typically accept just this one location, which is the AML. I would say about at least 10 a summer, if not a little bit more.
And thank you for already answering the question, what is the favorite part of your job? One last question, hold on. What's the favorite experiment you have ever done?
The favorite experiment. I'm gonna let everybody answer that one. I'm gonna save mine for last.
One time in AP chemistry, we took pennies and we turned the outside gold, and that was one of the coolest experiments I've ever done.
One that I thought was pretty surprising is that you can make a CD spontaneously break by spraying like pine sol on it. That was a very cool demo we did one time.
I would say in high school we had a teacher that took someone's Gatorade off their desk and they made a light bulb light up.
Let's see. I never really did chemistry experiments in school, but my favorite biology experiment was when we dissected a frog, and I accidentally spilled all its guts all over me. But it was.
I remember in actually the event I met Rico, Marissa actually made ice cream out of liquid nitrogen, which was really cool to see.
So
What is it?
What's your favorite experiment you ever done?
I really like the gas transitions when you pour the hot water in the liquid nitrogen.
So for me, I actually have two. I love the liquid nitrogen ice cream experiment and the Dippin' Dots, definitely because I get to eat it at the end. So I think that's a really good experiment. Second, I'll go from graduate school days where we used to do an Inferno experiment. You feel different flammable gases up in the balloon. You take a blowtorch to it and you see which one gives you the biggest flame. I think that's also a very cool experiment.
Nice.
Did you guys ever make dry ice?
Yes, we actually make our own in-house dry ice, especially when we're doing experiments. So we could do that with, you can get a siphon tube outside and put in a lot of pressure. So we actually make our own house.
I heard dry ice makes your feet freeze.
Dry ice make your what?
Your feet freeze because if you step on it, it makes your feet freeze in the water.
Well, liquid nitrogen does that faster because it's cold.
Who's your favorite work partner?
Okay, guys, go ahead and mute yourselves. There's one question about, and thank you for that. Who's your favorite work partner?
I would say here at Sandia, we all like working with each other. So everybody you saw today actually works in my lab. They're either a postdoc or intern in my lab. So we work together all the time. I would say that we give each other praises and the blues.
All right. That was so awesome. Thank you all so much. And again, this is all part of the New Mexico Science Fiesta. And would love it if you all went to this feedback form, bit.ly/feedback sci-fi. Tell us what you think. There's events and presentations going on all week. We have 3 or 4 going on each day. Thank you for telling me that. But we have presentations going on all week, 3 or 4 each day. So please join us throughout the week. On Saturday, we have the New Mexico Science Fiesta Expo, explosive demonstrations every day. Throughout the day. This is this coming Saturday, starting at 10 o'clock in the morning. And I want to thank our sponsors, including Sandia National Laboratories, as well as AFRL, Fidelity, New Mexico EPSCoR, HP, Acoma, Blue Cross Blue Shield, and Facebook. If you do social media, please tag us at New Mexico Science Fiesta, How We Explore, and STEAM for All. All right. So again, I put that the feedback is bit.ly feedback sci-fi. We do daily drawings for prizes. So go ahead and make sure you tell us what you think. Go to that feedback form. And thank you. Let's unmute ourselves and give a huge shout out and thank you to the entire crew of Sandia National Laboratories. Yeah, let's go.
Thank you. Thank you. Thank you.
Thank you.
Thank you.
Thank you.
Adios. Can you be my son? Can you be my dad?
The secret word is liquid nitrogen.
Those are awesome.
All right, bye, y'all.
How can we access the recorded video?
Yes, we're uploading those every day to the Science Fiesta YouTube channel.
Okay, the YouTube channel?
Yep.
I noticed some of my kids weren't there today, so all right.